So in this video, I'm going to discuss the make array odd problem which occurred in today's CODECHEF challenge. So if you have any doubt regarding this, you can ping me up on Instagram. Even you can join my Discord server. I will provide both the links in the comment section. I will pin them. So this is the number of test cases. You're given the n, that is the size of the array, and a number, I think it's x. Okay. And what we have to do is make the whole array odd. And what we can do is take two elements from the array, let's say ai and aj, and replace it with ai xor aj or x. Okay, so this is what we can do. We can replace ai by this and aj by this. Okay, so remember one thing, when we are dealing with bitwise thing, and since we have to make the whole array odd, so we don't need to think about what is in the remaining bits. Okay, we have to just take care of the last bit. Okay, just the last bit, because remember one thing, if the last bit of this, so let's say this is 0 or 0. Okay, so this becomes 0. If it's 1s or 1, that becomes 0 also. Okay, and the last bit is 0 when it is an even number, and the last bit is 1 when it's an odd number. So if it is already an odd number, there is no point of making it even, right? So this thing we don't need. So if this is a even number, if we XOR them, it becomes even, right? If one is even and another is odd, then the XOR becomes odd. Okay, so this is a very beneficial thing. This step is a very beneficial thing. And if it turns out to be 0 after making this OR, if this is the last element is 1, the last bit of x is 1, that is x is a odd number, then we can make this odd also. Okay, so what we have to check, first of all, we need to check whether x is odd or not. Okay, but before that one thing for this 0 case, that is, first of all, we can run a loop from I is equals to 0 to I less than n, I plus plus, and if ARR of I is even, then even plus plus, else odd plus plus, and both even and odd were 0 in the beginning. Okay, this is the basic thing, that is count the number of even, count the number of odd numbers. And once we are done with it, so we have like various conditions, like various cases. Okay, sorry. So the first case 1, if all are odd, okay, that is even is equal to 0. If even is equal to 0, print 0. Very simple. Case 2, if like this thing as I mentioned, like if let's say all are 0, okay, all are 0 and this is also 0, so there is no possibility to make it 1, right? That is, if all are 0 means all are evens, so there is no odd, and x is also even, right? And then x mod 2 is equal to 0. So in that case, we can be like, for sure we can write it as -1, right? Like we can print -1. And case 3 will be, if this is a very simple thing, if x mod 2 is equal to 0, like apart from this, if x mod 2 is equal to 0 but odd is like not equal to 0, in that case we can simply print the number of even. And case 4, that is, if x mod 2 is not equal to 0, that is, we have the freedom to do anything we feel like, so we can print even mod 2 plus even by 2. That is basically, this is basically seal of even by 2, right? So what we are doing in case 1, all are even, so all are nothing is even, so all are odd, so we need to do nothing. If odd is equal to 0, so that is nothing is odd, so all are even, so all have their last bit as 0, and x mod 2 is also equal to 0, so x also has the last bit as 0, so there is no possibility to make it even, so we print it -1. That is, let's say for 0 XOR 0 and 0, sorry, and it's not and, it's or 0, so it is always 0, right? So there is no possibility. So we print -1. Case 3, if x mod 2 is equal to 0, like leaving case 1 and case 2, if x mod 2 is equal to 0, so that is this is 0. Okay, this is 0, but there is at least 1 present over here, at least one present over here. So we can make 1 XOR 0 and 0, right? And this becomes 1. So this is a valid case. So we have to find the total number of zeros in it, that is total number of even in it, that is printing even. Remember, when I talk about 0, I mean the even numbers. When I talk about 1, I mean the odd numbers. Okay. In this, x mod 2 not equals to 0, that is x is itself 1. Okay. So if x is itself 1, anything, if I OR it with 1, it becomes 1, right? So it doesn't matter if it's 0 or 1, it doesn't matter, it is going to be 1. So it is most preferable to make it zeros or 0. That is, we are going to convert two zeros to 1 directly. Sorry, to 1. So when I say 0, what do I mean? Even numbers. And when I say 1, what do I mean? Odd number. So odd number, that is z, x is odd number, and this is, we are going to take two even numbers at a time and make them odd. So that is even by 2. But what if, like, we have got 5 even numbers? So we can take, so let's say if we have got 5 even numbers, 1 2 3 4 5. So we can take these two at once, these two at once, and this gets remaining. So that is why we can use the seal. And if you think that you don't know this thing, this function, so you can make it even by 2 plus even mod 2. That is, even by 2 is 2 and even mod 2 is 1. So 2 plus 1, that is 3. So we need 3 operations. So this is the basically the thing. Thank you.